All right, assignment 9, which is extra credit. One more chance to review and practice some of the things on your test. So just because they're not on this doesn't mean they're not on your test. First thing you might do is try it yourself. And then these are the answers, which you can check real quick. You can maybe pause the video and check them, write down the right answer. You might figure out what you did wrong on your own. And then you got some graphing calculator problems. So, all right. So now I'm going to go over these problems so you can figure out what you got wrong or what you got stuck on. So these first ones are converting fractions or converting repeating decimals into fractions, rational numbers, integer, ratio of integers. So this is where we say n equals, there's two repeat numbers, so we're going to multiply both sides by 10 squared, so it's going to be 100 n equals, now it's going to move the decimal place over 2 spots, right? And then you get the 2, but then it's a 6, and you could do that repeating, but when you subtract n, you want to line up the decimal place, and you want the repeating parts to line up. So let's say 6, 2 repeating like that, so these cancel each other out. So then we get 99n equals 35.9. Borrow from the 5. 12 minus 3 is 9. 5 minus 0 is 5. Divide by 99. But that's not a good final answer, so we're going to multiply top and bottom by 10 to move the decimal place. I don't want decimals in your fractions. It's a ratio of integers, so like that. And I'm fine with you not reducing these answers from those problems. And I don't think that one can be reduced anyway. So let's see. The next ones are interval notation and simplifying intervals. I like to draw these little pictures real quick. So let's see. Solid dots and open dots. Line them up just relatively correct. Now, this is union, right, which is the same as or, which means either one can be true. So it's going to go negative infinity all the way to 6. Bracket on 6 because 6 belongs, it just has to belong to 1. Union's like marriage. This is called intersection. An intersection of things are things they have in common, and it's the word and. So, open dot at 2, or the left, open solid dot at 2, solid dot at negative 3. So they both have to be true. So it's going to be negative 3 to 2. Bracket on negative 3 because it belongs to both. Parenthesis on the 2 because it only belongs to 1. It has to belong to both to be part of your final answer. Okay, next one is a rational inequality. That's already on one side, equals 0, single fraction, factored. I mean, this one's done as much as it can be for you. You should love this. Now, remember on the bottom, plus or minus 2 are both solutions. Now, these are going to be vertical asymptotes, right? This guy has a 2, so that one's going to bounce off the graph instead of actually going through it. And we're going to do a number line that just represents the x-axis. I'm going to do these left to right. The ones on top are going to be solid dots. The ones on the bottom are always going to be open. So negative 5 is a solid dot. Negative 2 is an open dot. Positive 1 is a solid dot. Positive 2 is an open dot. But 1 is that even multiple root. Test a value. You got to show me what you're testing. Write it down. I like to test far right. Positive, 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 which is false. True, stays true, false, true. So it usually alternates true, false, but it has even power and it stays the same on both sides. So your answer is going to be negative infinity, negative 5, bracket, parentheses on infinity always, union, parentheses, negative 2 to 2. Don't break it up at 1 because it's a solid dot. It's all one big chunk of answers. You break it up, taking off points. Okay, number 4, this is a polynomial inequality. So we're going to move everything to one side, equal to 0 by doing a little algebra on it. Factor it if you can. -3 plus 1, that works. So x equals 3, x equals -1 are zeros. We're going to do a line check. These are solid dots. No repeated roots, even number of times. No bounces off the graph. X equals 4, positive, positive, which is false. True, false. Your answer is -1 to 3 brackets. So these can be quick and easy. Let's see, number 5. This is another polynomial inequality. So we're going to move everything to one side. Equal to 0. And then now this is a cubic. If it had 4 terms, I might try grouping, but there aren't an even number of terms, so I can't try grouping. So I think we got to try rational root theorem, right? These are your P's. These are your Q's. So you get a list of P values, all the roots, possible roots, and then a list of Q values, and then you got to make a list of P over Q values. Now, if Q is just 1, then that's easy. It's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now, hopefully it's one of these nice earlier positive numbers, but start plugging these in, and they should give you a 0 in this one. So if you plug 1 in, you get 1 plus 1 minus 12 is -10. No, -1. -1 plus 1 is 0, -12. Nope. Positive 2. 8 plus 4 is 12 minus 12 is 0. Perfect. And I'm going to use synthetic division. Now, if there's any missing terms, you got to put a 0 there. There's no x to the first term, so you got to put a 0 for it. So drop the first term down, multiply by 2, add these, keep going, repeat. And at the end, you should get 0. If you don't, something's wrong. You forgot the 0 here, you picked the wrong root, you did something wrong. It's a good check. So now this guy came from x minus 2, and then this is going to be x squared plus 3x plus 6 less than or equal to 0, still there. And then we can try and factor this, x and x. Pair numbers that multiply together get positive 6 and add together get positive 3. Not possible. So they have to both be negative to make a positive, and they can't add 2 negatives. So we can't factor it. That doesn't mean there's no solution. It means we've got to do quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac. I'm really careful about this. Don't forget, all over 2a, which divides all of this. A lot of people like to just divide the first part. So what are we going to get? -3 plus or minus 9 minus 24. -3 plus or minus the square root of -15. So these are going to be imaginary because you're trying to take square root of negative, which means they're not going to show up as real intercept. So all we have is this one right here, x equals 2. We can do a line check with it. It's a solid dot at 2. Test a value. I don't know, x equals 3. Positive, everything's positive, which is false. True. There's your answer. -infinity to 2. Parenthesis bracket. There you go. All right. Number 6. If you have 2 absolute values, if it's an equal sign, don't do anything funky. Just do the 2 scenarios. If it has an inequality, you want to get rid of those absolute values. Square both sides. This is your best bet. 4x squared minus 12x plus 9 less than x squared plus 4x plus 4. And then this is polynomial inequality. So let's do what we just did on the last 2 problems. Move everything on one side, equal to 0. So we get 3x squared minus 16x plus 5 less than 0. Let's see if we can factor it. 3x, x. Pair numbers that multiply together get positive 5, add together get -16. It's got to be -1, -5. So you got to put them in the right spots. -5 gives you -15. -1 gives you -1, gives you -16. You can always check your answers on your factoring. You guys should catch it. Foil it out. See if you get what you just had. So x equals 1/3. X equals 5. line check. These are open dots, left to right, smallest, biggest. Test a value, write down what you test. So this is the kind of work I need to see. Give you full credit. Positive, false, true, false. Answer and interval notation. There we go. Okay. Now, number 7 is kind of like a problem that was on the pretest, but it's a little different. And it says write inequality. It doesn't say write an absolute value inequality. Now, if you tried to write an absolute value inequality, it probably wouldn't work because the middle of these would have to be the same. In the middle of these is 3. In the middle of these is 4. And then there's this extra lone dot over here. So that's not going to work. Okay? So we're going to have to... Now, we can't do a polynomial inequality. We could do a polynomial inequality if they were all solid or all open. But because some are open and some are solid, that means for sure it's coming from a fraction. Okay? So the open ones have to come from the bottom. X plus 5, x minus 13. The closed ones have to come from the top. X minus 2, x minus 4, x minus 17. Okay, and then they're going to be compared to or equal to 0. Now this guy, the fact that he's all by himself, that's one of those star ones, those bounces. So that means this guy has to have an even exponent. It could be any even exponent. I'm going to go with the simple one, 2. Now these, by the way, could have other exponents as long as they were odd, but that seems unnecessarily messy. Now, how do we figure out if this is greater than or less than? We'll do what you would normally do. Let's test x equals 18. Positive, 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 but it's supposed to be false. So that means it's got to be negative. There you go. There's your answer. Like I said, there are some variations. You can put any even power on this. You can put any odd powers on those. But you're not going to be able to write as a polynomial inequality or an absolute value inequality. Some graphing calculator problems. So can you type everything into your calculator correctly? Let's see. I'd put parentheses around 3/4 just in case. Times parentheses around at least the top. 4, 20 to the third root. Cube root is a 1/3 power. So make sure you put parentheses around the 1/3. Otherwise, it's not going to work. Divide by parentheses. 2 minus 3 e squared. Close that. That's your answer. Negative 0.249, rounded or truncated. 2.50. Now, I like truncating. It's hard to screw it up. Rounding, you can mess up because you got to do it right or you got to do it wrong. Truncating, you just chop it off. Okay, number 9, we're going to solve a rational inequality using our calculator because this one probably, it's just hard to do by your hand. What you should do is move everything to one side like you normally do when you do it by hand, but then that's it. There's no benefit to putting these in the least common denominator for your calculator. So I'm going to go to y, or I'm going to graph this. I'm going to put x squared divided by math num absolute value, x minus 3, minus 4 divided by parentheses, x minus 2. You definitely need parentheses in that denominator. I'm going to go to the window and say I only care about 0 to 6. Now, I don't know about the y values. I'm going to say negative 10 to 10 for right now. But I'm willing to change the window easily. Okay? We want to know where is this graph that we're going to graph right now above the x-axis. Let's graph it. There it is. Oh, you should know what that is. That's vertical asymptote, right? Now, this is a tricky problem. Let's sketch what we got right here. And 1, 2, 3, 4, 5, 6 is all we care about in the x direction. Now, there's clearly a vertical asymptote at x equals 2, right? And that's what's going on that graph. And then the graph kind of goes like this. Looks like it blows up. Not surprisingly, next to the vertical asymptote. And then it looks like it goes like this and blows up down here. Now we're saying, where is this above the x-axis? Well, that's this whole chunk right here. And then this chunk, right? And so you probably say, well, my answer is going to be 0 to 2, bracket parentheses, because we're including 0, and it is definitely above, but that's going to be an open dot right here, parentheses, because it doesn't exist. Union, whatever this x-intercept is, but it's got to be an open dot because it's just greater than. And then you probably think maybe all the way to 6 bracket based off this graph. Now I'm going to tell you, you should be expecting other vertical asymptotes in this graph that aren't showing up. X equals positive 3 should be a vertical asymptote, right? That causes division by 3. So you might be missing something here. So let's make the window a little bigger because I'm thinking something has to happen up here. So if I make the window, the y values to 20, y max. So there's that. What? But that makes sense. There's a vertical asymptote here. So sometimes my calculator connects them and sometimes it doesn't. So this actually goes like this. It blows up towards the vertical asymptote and then it comes back down over here. That's a big deal. So your answer is actually whatever this x-intercept is to 3 parentheses union 3 to 6. Now I pretty much got the answer without having done any calculations yet. I got to find that x-intercept. Second calc 0. It's between 2 and 3. Guess 2.5. And it is 2.4081893, comma 0. I need a sketch on your test for all these problems to give you full credit. It's going to also help me give you partial credit when you mess something up. 3 decimal accuracy, rounded truncated. That's it. That's the answer. So you got to watch out. You need to be looking at, hey, what are the things I expect to happen on this graph? Like vertical asymptotes. This guy right there, x equals positive 3, was a vertical asymptote. And if you missed it, then you might have missed something important happening on the graph. And then once you realize, hey, there should be something more to it, then be willing to resize the graph. Number 10, AB is a tangent line. Find the area. So we have the tangent line E the x looks like this, right? That's E the x. It's an exponential graph. And we have a tangent line right here, right? Tangent line, it's a curve. And it says that x equals 2. So I guess that's this point right here, x equals 2. And so we got to find the area of triangle ABC, which means I think we need the formula for the tangent line. So the quick way of doing that, let me see. I'm going to put this in my calculator. Now the quick way, let's go to window. I think -1 to 4 is probably enough. And then -1 to, let's try 10. Now I'm kind of based off this. Like I'd like to see the x and y axis on a graph because otherwise I feel like it gets confusing. So let's see, there's the exponential. And I mean, we could probably use, I don't know, I think that looks good. And there's 2. So the quick way of doing the tangent line is to go second program draw number 5 tangent line and type in x equals 2. It draws it and it gives you the formula for the tangent line down here below. Y equals 7.3890573. I think that's enough. X minus 7.389. Now the problem with this is illustrating the problem, is that it cuts it off. And because our slope had so many decimals in it, the y-intercept got cut off to 3 decimals, which is kind of bad, but I'll let it go. So that's the equation of your tangent line. So now you could use that to figure out the dimensions of the area of this triangle. You could treat it like a triangle. No matter what, you're going to have to find this x-intercept, right? So now that equation is not in your calculator yet. So if you want to make use of your calculator with that, you got to type it in 7.38905733x minus 7.389. Now, if you graph it, it's going to graph it right on top of it. Can't even tell. And you could use that to find its x-intercept. You say, well, it looks like it's close to 1. So 0 to 2, guess 1, and oh, you know what? Shoot, this is no sign error. The reason that did that was because it was looking for the x-intercept on my other curve. Number 5 or number 2. I was trying to find it by default goes to y1, which is this, and it has no x-intercept where I told it to look for it. That's what happens if it doesn't have an x-intercept. It says error, no sign change, because it's looking for it to change from positive to negative to indicate that it's an x-intercept. So we got to make sure we're on the correct equation, and then say 0 to 2, guess 1, and it is 0.9999224, comma 0. What are you? So, I mean, I bet that was supposed to be exactly 1 if we did everything exactly. Used some other calculus to find that slope of that tangent line. Then we could find, so we can use that to find the area of the triangle could be 1/2 base times height. And so that would be 1/2. The base would be 2 minus 0.999992224. The height is going to be whatever the y values of this line. So we could actually plug that in. That's at x equals 2. So that's going to be e squared, right? It's going to be e squared. So we could just use that, e squared. But e squared, or you could go on here, you could say second calculate value and say, I want the value at x equals 2. Now, by default, it goes to the first graph, but then if you go up or down, it'll switch graphs. So that is 7.389147. So you could use that instead. And so you could use that to find the area of that by just doing a triangle. Now, we'd have to go back out here and say 0.5 times, parentheses 2 minus 0.999999224 times 7.3891147, and we get 3.694586. Now I'm writing this because I think we might need this for the next part. The answer here for 3 decimal accuracy would be 3.694 or 3.695. Round or truncated. Now, let's try something else. What if we had put e squared in here? E squared probably should be pretty close to the same thing. Really close. At 5th decimal place, it's off. So you can see that, but that's fine. We have a good enough answer. The other way of doing it is from the graph screen to integrate. Now, make sure you select the correct curve, and then you got to type in the limits. It's 0.999999224. The upper limit is 2, and then I'll shade it in and give you the answer. Now, that would give us the exact same answer we got doing it the other way, round or truncated. At least at 3 decimals, it'll be the same. The other way, though, of getting the equation of the tangent line is to do second calc dy dx on the original curve at x equals 2, and it gives you the slope. Dy dx equals 7.389053. And then you can write your own equation of your tangent line by doing point slope form. Y minus e squared, that's a point, equals 7.389053 x minus 2. So that's the equation of the line, and then you could change it to slope-intercept form, which might be helpful. 7.389053x. Now, the benefit to this is I'm getting a much more accurate version of my tangent line with more than 3 decimals right here, and that might make a difference, but it would be 7.3890573 times -2 plus e squared. So it'd be minus 7.389085. So that's maybe a little better tangent line. But you look, and it's really close to this other one. I mean, really close. So anyways, that's just a different way of getting the tangent line yourself. I'm totally cool with you doing the draw thing, though. Now, the area of region R, that's this area right here. So let's figure out what our strategy is. I like to draw little pictures. So you can find this area, right? And then find the area of the triangle and subtract it to get this area that's left. Now, you got to be careful because Let's write the setup. The setup is going to be 0 to 2 of e to the x. That gives you that first chunk. Minus, you can just put the answer you got from part A here if you want. I'm fine with that. But probably the answer was more than 3 digits before you rounded it, right? So this is your setup. And if you did this one, if you did the triangle with the integral, then you got to show the setup for that. But I think this will work. Math 9. You could do the vars y vars thing, or you could just say e to the x again, comma x, comma 0, comma 2 minus 3.694586. So you get 2.694470. So the answer, final answer, 2.694, rounded truncated, comes out the same. So I don't know. I think drawing these little pictures is helpful. I'm not saying you have to do that, but I think it helps you. I do need the setups. I need to figure out what you're doing. I can't just see I have numbers pop out of nowhere. If you're doing area of a triangle, show area of a triangle clearly, right? If you're doing integrals, show the integrals clearly. Limits, you need the dx stuff. I'm going to complain about that. That's technicality. Okay, now number 11 is just kind of bonus. I'm not going to put something exactly like this on the test. It does involve some of the stuff we were just doing. But F average, this is kind of an interesting idea. If you take a curve and you say, well, I want the average value of the curve, then that means that's like the average height of the curve between these points. Okay? Now, the way we do it is we say, okay, well, let's take this curve and smooth it out. And then that would be the average, average height. That smooth out height would be the average height. Okay? So this is like a F average right here. And this is F. Now, okay, well, how does that help us? Well, let's think of the area under the original curve, and the smooth out curve is going to have the same amount of stuff underneath it, right? And it's going to be a rectangle. And it's the height of the rectangle that we want. That's the average height. And then the base, well, the base we can figure out. It's just going to be whatever the right limit is minus the left limit. So the way we do this is if you want to find the average of a function, you integrate it between the values you want the average of. That gives you the area under the curve. We then imagine it smoothed out. Now it looks like a rectangle. Same area, but a rectangle. And if we divide by the base of the rectangle, we get the height of the rectangle, which is also F average. It has a special name in calculus called the mean value theorem. So that's how you do it. And then you would keep going 1/6. It's a 1 to 7 natural log of x dx. So this is your setup. And then you could do this on your calculator. You could say, okay, math 9, natural log of x, comma 1, comma 7. And that gives you that answer. You could write that down if you want, or you could just divide it by 6. So then multiply by 1/6 or divide by 6, and you get 1.270228507. So the answer is F average is 1.270 rounded truncated, comes out the same. And that's the average height of whatever this graph. This graph, by the way, looks like this. And 1 is right here and 7 is right here. So it's finding the average of all these y values. But you're not going to have to do that specifically on this test, but it's a little sneak peek at some stuff that's going to come a ways later this year. So that was just some good extra practice. It's extra credit if you did it all. Okay. That's kind of your last chance at practice. Of course, you have lots of stuff. You go back and print out some empty worksheets, try it again as if it were the test, practice the kinds of problems that you need help on, and be ready for that test, okay? We're going to split it into 2 days, graph and calculator the first day, and non-calculator the next day. The non-calculator test is going to be the one that's going to be a time crunch. So I'll probably try and let you guys have a little extra time. If you are first period, I'll let you guys come in early, 10 minutes and get started. If you're second period, I'll let you work 10 minutes and break. Third period, come in 10 minutes early before break, lunch. Fourth period, work 10 minutes into lunch, etc. So, but that's still, you're still going to wish you had another half an hour, I bet. It's going to be, you got to be dialed in. It's not enough to just know how to do stuff. You got to know how to do it well and fast and accurate and show your work nice and neat. And the only way to get that good is to practice it. So it's not enough just to understand it. You got to be practicing it.